This is the chapters 5 and 6 exam review. Question 1. Solve the system by the method of your choice. We have 3x equals y minus 2 and 3x minus y equals 2. Now I might recognize that that top equation is solved for 3x. So I should be able to substitute y minus 2 into the second equation for 3x. It says 3x equals y minus 2. If I didn't recognize that, perhaps I could solve the top equation for y and plug that into the second. There are several different ways that I can solve this. I just happen to recognize that the top equation is solved for 3x. So I'm going to replace 3x in the second equation with the y minus 2. So I get in the second equation y minus 2 minus y equals 2. And look what happens on the left-hand side of this equation when I combine like terms. Y minus y is 0. So I end up with minus 2 equals positive 2. Well, that's inconsistent. Negative 2 does not equal positive 2. So this system does not have a solution. Or we say that its solution set is the empty set. So of my three choices, A, B, or C, my choice would be C. This does not have a solution. So if I end up with something that doesn't make sense, that's an inconsistent system. There's no solution, or its solution is the empty set. Now, if I had come up with something that was always true, like 2 equals 2, something of that nature, that means it's dependent. And that means there are an infinite number of solutions. And of course, if I come up with a distinct x and y, then it has a solution set, which is an ordered pair. Problem 2. The figure shows the graphs of the cost and revenue functions of a company that manufactures and sells small radios. Use the formulas below to find R of 500 minus C of 500. Describe what that means for the company. So we're going to evaluate the revenue function R at 500, and we're going to evaluate the cost function at 500, and then we're going to take the difference. So let's first evaluate the revenue function. So I'm going to evaluate R at 500 by replacing X with 500. So I have 48 times 500, and I get 24,000. Next, we're going to evaluate the cost function, also at 500. And I get 23,500. So when I take the difference of those two, I get 500. All right, so let's type that in. So what's this mean? If you subtract the cost from the revenue and you get a positive number, that means revenue is larger than cost. If your revenue is larger than your cost, then you are making money. You're making a profit. All right, so which of these 5 choices is correct? And it's important that you read all 5 choices completely. Choice A, the company is breaking even because cost and revenue are equal. Cost and revenue are not equal. Revenue is larger than cost, so A is not a choice. B, The company is losing money because revenue is greater than cost. Well, revenue is greater than cost, but that means the company is making money. Does not mean that they're losing money. So B is not a choice. C, the company is making money because cost is greater than revenue. Well, it is making money, but not because the cost is higher than the revenue. It makes money when the revenue is larger than the cost. So it's not C. D, the company is losing money because cost is greater than revenue. Cost is not greater than revenue. Cost is smaller than revenue. So D is not correct. E, the company is making money because revenue is greater than cost. Yes, the company is making money because the revenue at 500 is larger than the cost at 500. So the choice is E. All right. Looks like I have a frozen system here. All right, here we go. My system froze for a second there. All right, problem 3. Solve the system if there is no solution or if there are infinitely many solutions and the system's equations are dependent, so state. All right, I'm not going to have enough room in this little spot in my printout to solve the system, so I'm going to do it down toward the bottom of the document. So let's write C below here. And let me scroll down to the bottom. Okay, solve this system. So I'm going to solve this system using the methods that I got in chapter 5. So I'm going to choose any of the 2 equations and eliminate one variable. Then I'm going to choose any of the other 2 and eliminate the same variable. And although I think this system, it would be just as easy for you to eliminate X, Y, or Z. I think they're equally straightforward to do. I chose to eliminate Z. So what I'm going to do, I'm going to put the second equation by 6, and I'm going to add that to the first, and that will eliminate Z when I do that. So I'm going to multiply the second equation by 6. Then I'm going to add that to the first equation. Okay, let's do that. So we have 6 times x plus 2y minus c equals 6 times 0. So I'm going to be sure and multiply both sides of the equation by 6. So I get 6x plus 12y minus 6 times z is equal to 0. 6 times 0 is 0. Now I'm going to add that to the first equation. My first equation is 2x plus 10y minus 10y, excuse me. Let me erase that. Don't want to make a sign error. Plus 6c equals 28. Let's make sure we have that written down correctly. Looks good. Okay, now I'm going to add those 2 equations together. So 6x plus 2x is 8x. 12 minus 10 is 2y. The z's add to 0. 0 plus 28 is 28. So there's my first equation in x and y. Now I'm going to go back to my 3 equations. And again, I'm going to do the same thing to equation 3, and I'm going to add that to equation 1. So I'm going to multiply the third equation by 6, and then add that to the first equation. So I eliminated z from the first two. Now I am eliminating z from the first and the third. So multiply both sides of the equation by 6. (21 times 6 is 126. Now I'm going to add that to the first. Which was 2x minus 10y plus 6z equals 28. So 60 plus 2 is 62x. Minus 6 minus 10 would be minus 16y. Negative 6z plus 6z is 0. 126 plus 28 is 154. So now I have my two equations in two variables. And now I want to eliminate either x or y. And looking at these two equations, I'm thinking that if I multiply this first equation here, if I multiply that by 8 and add it to the second equation, that would eliminate y. So that's what I'm going to do. I'm going to multiply that equation by 8. So I get 64x plus 16y equals, I'm going to take my calculator out and multiply 8 times 28 because I'm probably not going to be able to do that in my head. And I get 224. Now I'm going to add that to the other. And I get 62x minus 16y equals 154. I could write that a little bit neater, couldn't I? So I get 128x equals 378. And that isn't 128, that's 126. I can't add in my head, that's why I need a calculator. All right, divide by 126, and I get x is 3. So I've got the first number in my ordered triple. Now I'm going to back substitute into either one of these two equations, either the 8x plus 2y equals 28 or the 62x minus 16y equals 154 to find y. And it looks to me that the first equation would be a little bit easier for me to do. So I'm going to plug into that first equation. I'm going to plug in x equals 3 and solve for y. All right, so I'm going to subtract 24 from both sides. Divide both sides by 2. And I get y is 2. So x is 3 and y is 2. Now I need to find z. So I'm going to back substitute in one of the three original equations to find z. And I'm going to choose the first one simply because the coefficient on the z was a positive number. So I have 2x minus 10y plus 6z equals 28. So plug in 3 for x and 2 for y. Solve for z. Combine like terms. Add 14 to both sides. 28 plus 14 is 42. Divide both sides by 6, and we get C is 7. So the ordered triple, that is the solution to this system, is that X is 3, Y is 2, and Z is 7. So that would be 3, 2, 7. So you write the ordered triple with parentheses around it. X comes first, Y comes second, Z comes third. My math lab provides the braces for you to type that in. All right, problem 4. Solve the system by the method of your choice. And this is a nonlinear system of equations because the top equation is not a line. However, the second equation, hopefully you recognize that the second equation is a line. The top equation is not a line because I got an x squared and I have a y squared, so that's definitely not a line. Now, we didn't go over what the shape of this graph looks like in class, but it is an ellipse. So what you would have, you have the possibility of something like this. So you have the possibility that these two things could intersect at two different points. So your solution could be two ordered pairs. So we're going to solve this below 2 because it might take us a little bit of room to do. All right, I would solve this by substitution. Definitely would be the easiest way to do this. I'm not even sure that you could solve this by addition. That would be more complicated than I want to deal with. So that second equation is linear. So it'd be really, really easy to solve that for X. So that's what I'm going to do. So I'm going to subtract Y from both sides. All right, now I'm going to plug that into the top equation for X. So I'm going to replace the X with 30 minus Y. All right, it's really, really important that you remember how to square a binomial. How do you square 30 minus Y? You square it by squaring the first term. 30 squared is 900. The second term is going to be minus because that's the difference of these two terms. You multiply the 30 times the y, you get 30y, and then you multiply that by 2 and get 60y. Then you square the y and get y squared. So those first 3 terms are that binomial squared. Now this is quadratic, and I know it's quadratic because of the y squared. So I need to get everything on one side and 0 on the other, and then factor it. So I'm going to first combine like terms on the left-hand side. Y squared plus 2y squared would give me 3y squared. I'm going to subtract 900 from both sides. And this is actually very nice that on the left-hand side, the 900 subtracts off. So I'm left with negative 60y plus 3y squared equals 0. I'm going to rewrite that. As 3y squared minus 60y equals 0. This is the easiest quadratic that you can factor since there's no constant term. You don't have to factor this to a binomial times a binomial. The only thing you need to do is factor out a common factor. 3 and 60 have a common factor of 3, and y squared and y have a common factor of y. So the common factor I'm going to factor out is 3y. So when I factor a 3y from the 3y squared, I have a y left over. When I factor a 3y from a negative 60y, I have negative 20 left over. You want to be sure that you check that real quick by distributing to make sure you factored correctly. Now we set each factor equal to 0. Divide both sides by 3 for the first one, and I get y is 0. Add 20 to both sides here, and I get y is 20. So my two values for y are 0 and 20. When I started solving this system, I solved the second equation for x. So I do have that x is 30 minus y. So I can plug the two values that I got for y into this equation and find the x coordinates for that particular y. So if y is 0, I get x is 30 minus 0, or x is 30. So the first ordered pair that's a solution to this system of nonlinear equations is 30, 0. X is 30, y is 0. To find the second ordered pair, we're going to let y equal 20. So x is 10. So the second ordered pair, x is 10, y is 20. So there is our solution set. All right, problem 5. I'm going to start our graphing of inequalities in problem 5. The first inequality that we're going to graph is y is less than 2x minus 1. I would graph this using slope and intercept since it is already in slope-intercept form. So the y-intercept is -1, so I would plot that. The slope is 2. So I'm going to go up 2 and over 1. So I'm going to plot a point at 1, 1, and then that'll draw my line for me in my MATLAB. Now, I do need to draw this as a dashed line. Since I have less than, not, less than, or equal to, I draw this dashed. All right, since I'm graphing a linear inequality, the solution set of a linear inequality is a half plane of ordered pairs. So you're going to either shade the plane above the line, or you're going to shade the plane below the line. And just looking at this, you have y is less than, so you might assume that you shade below the line, which is true. However, we saw in the book that we were going to use a test point. So pick a point either above the line or below the line, test it in your inequality. If it works, shade the plane that contains your test point. If it doesn't work, shade the other plane. So we've been testing 0, 0. So I'm going to plug 0 in for y. I'm going to plug 0 in for x, and then I'm going to see what happens. So I get 0 is less than -1. That is not true. That is false. So 0, 0 is not in the solution of this inequality. So you do not shade the plane that contains 0, 0. You're going to take your bucket tool and shade the other plane, the plane that does not contain 0, 0, or in this case, below the line. All right, problem 6, you're going to be drawing a system of linear inequalities. You're going to graph those, and I would graph these using intercepts. I wouldn't solve for y and use slope intercept because it's just a little bit more work and too many places for me to make a mistake. Intercepts are really, really easy for me to find in these two. Perhaps your intercepts would turn out to be fractions. And if that's the case in your problem that you're doing on your exam, then maybe you'd want to use slope intercept or pick points. You can always pick an x, find y, and plot those. On my first inequality, 3x plus 6y is less than or equal to 6. If I look at the equation to find the intercepts, it's really, really easy for me to find the intercepts. The x-intercept, I just get rid of the y. I get 3x is 6, so x is 2. So I'm going to plot that. The y-intercept, just get rid of the x. 6y is 6, so y would be 1. So I'm going to plot that. And then I'm going to graph that line, and I would graph it as a solid line because I do have less than or equal to. Not the perfect line, but you get the gist. All right, the second one, the x-intercept would be 10. Excuse me, the x-intercept would be 5. The y-intercept is 10. All right, now I need to determine which of these 4 areas formed by these 2 lines is the area for me to shade. I have this area 1 here, this area 2 here, 3 here, and 4 is that little spot over there. And I'm going to do that by picking a test point. If it works for the test point that I choose, I shade the area that contains that test point. If it doesn't work, then pick another test point in one of the other areas. For example, in area 1, you could pick something on the x-axis like 8, 0. In area 2, you could pick 4, 0, or maybe something on the y-axis like 0, 6. In area 3 contains the origin 0, 0. So that's what I'm going to test to see if it works. Area 4, I would just have to look at area 4. I kind of covered it up, but find a point in area 4 to test it. However, if I've tested 1, 2, and 3 and it doesn't work in any of those areas, then I would shade area 4. I'm going to test 0, 0. So in the first inequality, the whole left-hand side of that inequality would be 0. That is true. In the second inequality, the whole left-hand side would be 0. That is true. So since it's true for 0, 0, it's true for every point in area 3. So that's what I would shade. All right, problem 7. Problem 7 contains 3 linear inequalities. However, the second and the third inequalities are vertical and horizontal lines. So I'm going to graph the first inequality using intercepts. If I don't have a y, if y is 0, 3x is 6, so x is 2 is the x-intercept. The y-intercept, if I don't have an x, y would be 6. So there's my first line. And it is a solid line because I have less than or equal to. The next line, inequality, excuse me, is x is greater than or equal to -5. That would be a vertical line at -5. X equals a constant is a vertical line. The third inequality, y is less than or equal to 3. That is a horizontal line at y equals 3. Y equals a constant is a horizontal line. Right, now I need to determine which of these areas I shade, and there's a bunch, 1, 2, 3, 4, 5, 6 different areas. So which of these 6 areas do I shade? Well, I'm going to pick the test point 0, 0. Now, I could probably look at this and figure out which area it's going to be. If y is less than in the first one, it would be below. If x is greater than in the second one, it would be to the right. If y is less than, then that would be below. So I could probably figure it out. But I'm going to test 0, 0. So in the first inequality, the whole left-hand side is 0. That is true. In the second inequality, x is 0. That is true. 0 is bigger than -5 because it's to the right of -5 on the number line. In the third one, 0 is less than 3. That is true. So I'm going to shade the area that contains my test point 0, 0. Again, if 0, 0 doesn't work, start picking points in the other 5 areas. So perhaps you pick a point on the x-axis like 6, 0, test it. Then you would shade that if it was true. You just keep picking test points until you find a test point that works, and then you shade that area that contains that test point. All right, problem 8. Problem 8, all you have to do is write the augmented matrix. So you're going to input the 12 elements in this matrix. So I normally input my elements in my augmented matrix by columns. The first column in my augmented matrix are the coefficients on my x's. So for this particular system, my first column, the first coefficient on x is 1. However, the other 2 equations, x is missing, so the coefficients on x in the second 2 equations are 0. So the first column is going to be 1, 0, 0. Now, in MyMathLab, you can input this by rows or columns by clicking wherever you want to in the augmented matrix. The second column are the coefficients on my y's. My first equation, the coefficient on y is -1. In the second equation, the coefficient on y is +1. In the third equation, y is missing, so the coefficient on y is 0. So I'm going to get -1, 1, 0. The third column in my augmented matrix is the coefficients on my z's. So what do I have? 12, -9, 1. And then my fourth column is my constants. Now, since my grade depends on getting this inputted correctly, I am now going to check each equation by rows. So the first equation, x minus y plus 12z equals 5. The first row of my augmented matrix should be 1, -1, 12, 5. The second equation, 0x plus y minus 9z equals -8, should be The second row in my augmented matrix should be 0, 1, -9, -8. Now I'm going to check my third row. 0x plus 0y plus z equals 3. So I should have 0, 0, 1, 3. I am good to go. Problem 9. Use Gaussian elimination to find the complete solution to the system of equations or show that none exists. Actually, I'm going to use Gauss-Jordan elimination to solve this. Because my calculator can do Gauss-Jordan, reduced row echelon form, just as easily as it can do Gaussian elimination, row echelon form, why not use Gauss-Jordan? Because if I use Gauss-Jordan, the fourth column in my new augmented matrix will be my solution set. So the first step is to write the augmented matrix down so that you can input it into your calculator. So I'm going to write that down here. So I get 6, 3, 1. The coefficients on my x's is my first column. My second column are the coefficients on my y's. 3, -3, 1. The next column is z. And then the last column is my constants. And I write the vertical bar separating the coefficients from the constants. There's no vertical bar in your calculator. You're just going to kind of ignore that when you put this in your calculator. Let me do a quick check here. So I should have in my first row 6, 3, 2, -5. 6, 3, 2, -5. Second row should be 3, -3, -4, -5. And the third row should be 1, 1, -1, 7. So I am good to go to my calculator and input this augmented matrix and use Gauss-Jordan elimination. So I'm going to share my calculator. All right, so I need to go to my matrix menu. For me, that's above my inverse button. So I'm going to do second matrix. And I'm going to edit. I'm going to put this in matrix A. So I'm going to go over to edit, and I'm going to edit A. So I'm going to hit enter. This is a 3-row, 4-column matrix. So it's a 3 by 4. So 3, enter, 4, enter. So my calculator, you can see, has created the 3-row, 4-column matrix for me. Now I just need to input my elements by rows. So my first row was 6, 3, 2, -5. 6, 3, 2, -5. All right, my second row was 3, -3. Make sure you're using the minus sign down here by the enter and not your minus sign subtraction. Make sure you use the right minus sign. -4. It will throw an error. It will tell you that it's wrong. -5. And then my last row, 1, 1, -1, 7. All right, so I have my paper here, and I'm going to do a quick check to make sure that I've inputted this correctly. Got my paper, so I'm going to make sure that I haven't made a mistake inputting this. 6, 3, 2, -5, 3, -3, -4, -5, 1, 1, -1, 7. If I had made a mistake, then I could just use my arrow keys and go to that element and correct it. All right, so now that I have my matrix into my calculator, I'm going to exit from the matrix menu. It's important that you do this step. So we do a second quit to get out of the matrix menu. Now I'm going to go back in. The reason I have to exit is because if I stay in there, whatever I type is going to input that into that first row, first element. So I need to get out of there before I can do any math. So now I'm going to go back in my matrix menu. I'm going to arrow over to math, and then I'm going to go find RREF, reduced row echelon form. So I'm going to arrow up. It's B. I hit enter. Now my calculator is waiting for me to tell what matrix I want to put into reduced row echelon form. That was matrix A. So I go back to my matrix menu. Number 1 is A. Close your parentheses and hit enter. So looking at this, I can see my solution set. The solution, ordered triple solution, will be the 4th column, because that first row says that x plus 0y plus 0z equals -2. X is -2. The second row says 0 plus y plus 0 equals 5, or y equals 5. So the second coordinate in my ordered triple, y is 5. And then the last row says z equals -4. So my solution is the ordered triple, -2, 5, -4. So go back to my document. So I had -2, 5, -4. Helps if you write it in the correct spot. All right. Problem 10. Find the determinant of a 2 by 2. Gosh, for me, this is just as easy to do by hand than taking a calculator out. To find the determinant of a 2 by 2 matrix, you multiply the main diagonal. So you multiply 1 times 4. Then you subtract from it the product of the other diagonal, which would be 4 times 4. So you just need to make sure that you subtract. And this formula is on your formula sheet, or perhaps you've written it down on a sheet of paper, but you do need to know this formula. You multiply the main diagonal and you subtract from it the other diagonal. So this would be 4 minus 16, which would be -12. All right, using Cramer's rule to solve 2 different systems, we're going to solve a 2-equation, 2-variable system, and then we're going to solve a 3-variable, 3-equation system using Cramer's rule. For me, the 2-equation, 2-variable system is just as easy to do it by hand as it is to put all those matrices in my calculator. So I'm just going to do this by hand. So we need to find 3 determinants to solve a 2-equation, 2-variable system. The first determinant we need to find is the determinant of the matrix formed by the coefficients on x and y. So it's the determinant of this matrix here. The determinant of the matrix 4, -3, 7, 3. So when I do that, I multiply 4 times 3 and subtract from it -3 times 7, and that is 33. The second determinant I need to find is d sub x, and that is the determinant of the matrix, taking the matrix D and replacing the first column, the x column, with the constants, find the determinant of that. So I get 6 times 3 minus -3 times 27. And I might let my calculator help me with that. I get 99. And then the last determinant we need to find is d sub y. And that's the determinant of the matrix formed by replacing the Y column in D with the constants. So that is going to be 4 times 27 minus 6 times 7. And my handy dandy calculator tells me that is 66. Okay, so now to find x, I divide d sub x by d. And that is 99 divided by 33. That is 3. And to find y, we divide d sub y by d, which was 66 divided by 33, which is 2. So the solution set to that system is the ordered pair 3, 2. All right, now let's solve the last problem on the review, problem 12, using Cramer's rule. So now I need to find 4 determinants, and I am going to let my calculator help me with this. 3 by 3 determinants are really not too terribly difficult to do by hand, but there's lots of places to make sign errors. So I'm probably better off letting my calculator do this for me. So what are the 4 determinants I need to find? I need to find the determinant D, which is the determinant of the matrix formed by the coefficients on x, y, and z. So that's 1, 0, 3, 0, 5, 3, negative 1, negative 1, 0. So I'm going to do a quick check of that to make sure that I have that written down correctly. The first row should be 1, 0, negative 1. The second row should be 0, 5, negative 1. The third row should be 3, 3, 0. And I'm going to put that in matrix B in my calculator. I think I have matrix A taken up using, when I put the previous problem in using Gauss-Jordan elimination. So if I don't have anything in matrix A, I could put it in there. But I always kind of make a note to myself where I'm putting that, so I know what I'm doing here. So let's find d sub x. What we do is we replace that first column in the previous determinant with the constants. And then the other 2 columns are the same. And d sub y, we take that determinant d and we replace the second column, the y column, with the constants. And d sub z, we take that determinant d and we replace the last column, the z column, with the constants. Okay, so let me make myself a note. I'm going to put this in C. D sub y I'll put in D. And I'll put this in E. Make sure I have all of those written down correctly because I don't want to make an input error. Just doing a quick check what I have in each equation. I want to make sure that everything is written down correctly. All right, so I look good to go. So I'm going to go to my calculator. And I'm going to go to my matrix menu. And I'm going to go over to edit, and I'm going to edit B. And I'm going to put that matrix D in there, find the determinant D. So it's a 3 by 3, 3 rows, 3 columns. And let me type that in. 1, 0, negative 1. And the second row is 0, 5, negative 1. And my third row is 3, 3, 0. All right, I'm going to make sure that I have that inputted correctly. It looks good. So I'm going to exit out of my matrix menu. I'm going to go back in, and I'm going to find the determinant of matrix B. So I'm going to go over to math. Number 1 is DET, that's determinant. I'm going to find the determinant of that matrix B. So go back into my matrix menu and choose that matrix and hit enter. So it looks like that matrix is the number 18. So I'm going to write that down on my piece of paper. Now I'm going to input D sub X. And I'm going to input that into matrix C. So I'm going to go over to edit. I'm going to edit C. That's a 3 by 3 matrix. Now I'm going to input the rows for D sub X. So I have -3, 0, -1, -3, 5, -1, -18, 3, and 0. Make sure that I have that in correctly. Just do a quick check, checking my paper. Okay, it looks good. So now I'm going to find the determinant. So I first need to exit out of the matrix menu. So I do a second quit. Then I go back in the matrix menu. I go to the math menu. Oops, I have issues. Here we go. To the math menu, I'm going to find the determinant. So that's number 1. I'm going to find the determinant of matrix C because that's where I put that. So I have to go back in my matrix menu, pick matrix C, close my parentheses, and I get -90. So I'm going to write that down on my piece of paper. D sub X is -90. I'm going to repeat with matrix D. That was going to be the D sub Y. I put D sub Y in matrix D. So go to my matrix menu. I'm going to edit D, which is number 4. I'm going to put a 3 by 3 matrix in there. Let me input those values. I will check after I get these inputted to make sure I did it correctly. Quick check. 1, 3, -1, -3, -1, 0, -3, -1, 3, -18, 0. Okay, I'm going to exit out of my matrix menu, go back in. I'm going to go to my math menu, number 1, and I'm going to find the determinant of that matrix D. So I go back into my matrix menu, choose D, and I get -18. So I'm going to write that down. All right, last matrix. We're going to put that D sub Z into E. So we're going to edit. Number 5 is E. It's a 3 by 3. 1, 0, -3, 0, 5, -3, 3, -18. All right, let's see if I got that in there correctly. 1, 0, -3, 0, 5, -3, 3, 3, -18. So now I'm going to exit from my matrix menu, second quit, go back into my matrix menu. I'm going to go to my math menu, number 1. I'm going to find the determinant of matrix E, and that is -36. All right, so let's go back and share. We've written all of this down on our sheet of paper. So I have them all written down. D is 18, D sub X is -90, d sub y is negative 18, and d sub z is negative 36. So now to find x, we take d sub x and divide it by d, which is negative 90 divided by 18, and my calculator says that is negative 5. To find y, we take d sub y and we divide it by d. That is negative 18 divided by positive 18. That is negative 1. And z is d sub z divided by d, which is negative 36 divided by 18, which is negative 2. So my solution, the ordered triple, is negative 5, negative 1, and negative 2. And that is the end of our chapters 5 and 6 exam review.